Hi, this video is about the Caribou Mathematics Contest. I'm going to show the solution for the May 2015 Grade 9-10 Contest, question 17, which also came up in the Grade 11-12 Contest. So the question is, 5 friends decide to work together to create a babysitting club. They quickly get many offers from the community. The friends decide to babysit a household in teams of 2. Tammy is put in charge of pairing up friends and making the schedule. Tammy works out the schedule so that each member has to babysit 2 times, each time with a different friend. Ignoring the order and times of the jobs, how many different schedules could Tammy have possibly created? Alright, so now we have to think, how can we make a simple and effective visual representation of a schedule? And when we have that, then we can find all different possible schedules. So in the question, we are dealing with 5 friends. So we can represent those 5 friends with the letters A, B, C, D, and E. And also, in the question, we are dealing with pairings. So an easy way to represent that, or to show that, would be drawing lines from a letter to letter, which would then represent one picking. And now the simplest way to show all that would be by putting the 5 letters in the form of a circle. Okay, so let's do that. Okay, so now we know that all 5 friends in the question all need 2 different partners, because they need to babysit 2 times, each time with a different partner. And they're all treated equally with the purpose of this question. So without the loss of generality, let's find all combinations of 2 partners for A. Okay, so for the first partner, for A, there are 4 different possibilities. And then for each of those 4 possibilities for the first partner, there are 3 other possibilities for the second partner. So we have 4 times 3. But in this counting, the order did matter. So for example, we C and D, or D and C, the order did matter. But in the question it says ignoring the order, which means that the order doesn't matter. So therefore we would have to divide this by 2, because 2 of the C and D, or D and C, they both give a combination. It's one and the same combination. So therefore that's why we must divide this by 2. So we have 4 times 3 is equal to 12, divided by 2 is 6. So there are 6 different combinations for 2 partners for A. Okay, so now let's show 1 out of 6 of those cases for A, for a case of A. And one of those cases, what would be that A is partners with B and also C. Okay, so now again, this would work for all letters, but without the loss of generality, we will just do this for A. Okay, so let's see if B and C could be partners. Now if B and C would be partners, well, now A, B, and C would all have 2 partners, and E and D would have to be partners, and then they would only have 1 partner. So therefore that would not work, and B and C could not be partners. Okay, now let's see if B and D can be partners. Okay, and now we can see that A and B both have 2 partners, and we can see that E here does not have any partners. So, since E does not have any partners, that means that E must be partners with D and also C. And finally, D would, well, now all of them have 2 partners. So that would work. Okay, and now finally let's see if B can be partners with E. Well, now again, A and B both have 2 partners, but D does not have any partners. So therefore, D must be partners with C and also E. Excuse me. So now we can see again that this works because all the friends have 2 different partners. So now we can see that for the case that B and C, but also for any of these 6 cases, there are 2 different ways to complete this case to a full schedule. So therefore, we must multiply the 6 by 2. And that will give us 12 different possible schedules. Now, the key to solving this problem was finding a simple way to make a visual representation of a schedule. If you'd like to know more about this contest, please feel free to visit our website at cariboutests.com.